Hello, everyone. Welcome to ITS 140. All right, so I'm just letting everyone in. Okay, let's get started then. All right, so you should be seeing the slides. If you remember, last week we started our discussion of iterative structures and loops. Today we're going to continue with that, and I'm going to assign your next homework assignment, which will be related to this repetition structure. So as usual, I will post a PDF scan of some kind of the problems, and then I'm just going to list out the ones that I want you to work on to submit. And then you will do the same thing you always do. You'll do the flowchart, the pseudocode, and the Python code. Okay. So that's the plan for today. So it should be really just wrapping up these slides, which is where I'll start. And then after that, going over some problem examples. And that should be it. Before I get started, are there any questions?
No.
Questions. All right. All right. So let's go ahead then and just continue. Okay. So, remind you repetition structure. So we were talking about, the famous for loops. Famous for loops. So if you remember, I didn't give you an assignment last week just because of the exam. And now we're going to continue with this today. So just I'm going to go over these quickly since we've covered them already. So if you remember, we talked about the while loop, right? We talked about how to do the flow charts, right? So we've discussed that. So we talked about, this slide. We talked about this flow chart as well. We talked about infinite loops, and that's just forgetting how to stop our loop. We talked about, I remember we talked about this, right? The for loop, where this, we stated that it was a list basically, right? An iterable object, right? And then we went over this example, and I kind of gave you this idea that you can think of this as a bucket, right? And if you think of it as a bucket or a pipe, basically, with a line of tennis balls, then, you're just grabbing each one out of there. And your hand is like the variable num, so you're really, you can look at it that way. Another way, that might be another analogy that might be a little bit useful also is like a scoop, right? So if you think, it's like you have almost like ice cream scoops, right? So it's ice cream, and then num, like the ladle. So you have num here, and that's that. And then you have the list here. So you're basically grabbing each one of those, carrying it in num, and then num over here, then it's like it pours into print. If you want to totally go into that analogy, you have a bowl over here, right? And the bowl is print. So you're literally like grabbing through that in there. And that's the same analogy. So just practice this, it'll make sense. But that's one of the things that I really like about Python. Very handy that way. Everything is an object, and so you'll be able to appreciate that a lot more later on. All right, so we talked about iterable objects. As I said, you can see that there. Already defined. We talked about the range characteristics. So we talked about 1 argument, 2 arguments, 3 arguments, right? Where the 3rd argument is the step value. Okay. All right. So So using the target variable inside the loop, the purpose of the target variable is to reference each item in a sequence as the loop iterates. So that's, the scoop in the, in the ice cream analogy. Target variable can be used in calculations or tasks in the body of the loop. So that's, again, target variable is the scoop, and you pour everything into the print bowl, if you will. And so you're carrying the value that way from the list to wherever you want to use it inside the for loop. All right, so we have here an example: calculate the square root. Calculate the square root of each number in a range. All right, so letting the user control loop iteration. So sometimes the programmer does not know exactly how many times the loop will execute. So I think this was the last example we did last week, I believe, when we were reading in numbers, but we were able to stop when we read the negative number, right? So if you remember, that was the last, we did a Python script, I remember of that. And we were just in a for loop entering, or a while loop, can't remember. We were just entering values in, and then once you entered -1 or some negative number, it would just stop. All right, so you could also input the range values from the user. Right? So that's also a possibility. Okay. So be sure to consider the end cases. Range does not include the ending limit. So you should try to consider that when you're creating. You should always stop your loops. Generating. Let me move this. Generating an iterable sequence that ranges from highest to lowest. So that's just doing things in reverse. So the range function can be used to generate a sequence with numbers in descending order. So you want to make sure the starting number is larger than the end limit. And then you have a step value, which is negative, right? So you can see here the range goes from 10, 9 to 8 to 7, 6, and so on, ... until it reaches 0, because the step size is negative. So you're literally decreasing or counting down. Calculating a running total. So we talked about this. We introduced the word accumulator. And we also did an example of this, I think, where we combine reading in values, stopping at a negative value, but also taking whatever, I think it was a cash register, and we had receipts. So we have a whole bunch of receipts from a cash register, and you were just entering those into your system. So programs often need to calculate a total of a series of numbers. It's very common. So this will include two elements: a loop that reads each number in series, and then an accumulator variable. So it's a program that keeps a running total and accumulates total and reads in series. All right, and then at the end we just print out the results. All right, here is the flow chart. So you can see the accumulator starts at 0. Right, and then if there's have we reached the end, like, is the value negative, right? So it could be in a statement, some kind of a conditional. If it's not true, then just keep read the next number and add the number to the accumulator. So the accumulator now is going to increase. And then we started talking, I believe we actually got into these, the augmented assignment operators, the plus, equal, As I said to you guys, I'm not gonna require you to use these right away. You don't have to. If you want to just write things that way, that's perfectly fine. Okay? I have, to me, it's the efficiencies that you're going to get out of that, are not really that much with today's computers anyway. So that's not really where where you're going to like speed up anything. So really, as far as what you're doing, just make it more readable. If that's more readable to you, that's perfectly fine. Remember that these symbols, they're just the basic adding, subtracting, multiplication, division, and modulus, the mod operation, which is very important. I might do an example of mod today. Actually, remind me, just because in it actually, you might see it sometimes and you think it's not very, what is that for? When am I ever going to use that? Well, actually, it has its uses, its usefulness. It's used in cryptography, first of all, but beyond that, actually, we can use it in just about any program. Sentinel, special value that marks the end of a sequence of items. Okay, when program reaches a sentinel, it knows that the end of the sequence of items was reached and the loop terminates. Must be distinctive enough so as not to be mistaken for a regular value, so the negative value that we use. All right, as far as files, don't worry about that yet. We will cover files later on in the semester. Files are very useful and very necessary. All right. Input validation loops. So these are also very interesting ones. We might do an example of that today as well. So I'd like to do modulus and also input validation. And that's just making sure that we have the right number before you're allowed to go and do something else. We have to tell it, tell the computer what is good data. So there's this famous phrase, garbage in, garbage out, and you want to avoid that, right? So to avoid garbage out, you need to make sure that there's no garbage in. Okay. Yeah. So definitely you want to prevent bad inputs, and that's for quality and also for the security of your program. You want to ensure that that doesn't happen. So if input is invalid, prompt user to enter correct data, commonly accomplished using some kind of a loop, right? A while loop maybe, which repeats as long as the input is bad. And so, for instance, you have people are trying to enter their email. Well, you can check that it contains the @ sign, it should have 1 dot, things like that. And then you want to notify the user if you found something wrong with it by showing some kind of an error message. All right, so here's the flow chart. So you get input. Is this a bad input? If not, you display the error and then you try to get the input again, go back into the loop and so on. So you're kind of in that loop like that. Nested loops. Okay, I remember we did not cover nested loops. Okay, so that's a third thing I'd like to cover today. So, I've said mod, input validation, and the famous nested loops, which are really a lot of fun. Okay. Okay. So example. So what is a nested loop? First of all, a nested loop is a loop that is contained inside another loop. So what does that mean? It means that you have, how we had for I in range 10, right? Colon. Well, now that for loop could be inside another one for J, notice that the index needs to be different, right? So that they don't get confused. For J, in range, and then maybe this could be 20, you know, just some, they don't have to be the same number. But if you notice, this for loop is inside that other loop, right? So what is contained within the other one, it's got that indentation. Okay. So an example of this is an analog clock. So let's read this for a second. Right, so an example, an analog clock works like a nested loop, right? So hours, hands move once for every 12 movements of the minute hands. So for each iteration of the hours, do 12 iterations of the minutes. Right, so second hands moves, or the seconds hand, sorry, the hours hand moves once. So let's look at this again. So the hours hand, okay, moves once for every 12 movements of the minutes hand. Yeah. For each iteration of the hours, do 12 iteration of minutes. So this I think makes more sense. All right. Seconds have the seconds hand moves 60 times for each movement of the minutes hands. For each iteration of minutes, do 60 iterations of seconds. Yeah, okay. So there's 60 seconds in a minute. It's worded really strange. Okay, so now we have a clock simulator. Wow, so we're gonna do a clock simulator here. So we start, is there another value in the hours list? Right? Yes, then assign the next value in the hours list to the hours variable. Is there another value in the minutes list? Yes, assign the next value in the minutes list to the minute variable. Is there another value in the seconds list? Yes, assign the next value in the seconds list to the second variable. And then print hours, minutes. Okay, I see where this is going. Okay. So let's try to do that watch in a second. Okay. Nested loops, key points about nested loops. Inner loop goes through all of its iterations. Inner loop goes through all of its iterations for each iteration of the outer loop. That's true. So you start one iteration of the outer loop, and then the inside loop will execute all of its iterations before you move to the next iteration of the outer loop. Inner loops complete their iterations faster than outer loops. Sure. Not faster because they're somehow in the CPU faster. They will perform all the iterations. Total number of iterations in nested loop is number of iterations inner times number of iterations outer. All right, and then summary. Okay, good. All right, so we have a few examples to do. Discard that. Let me just look at the other set of slides to make sure I've covered everything. So I'm going to do the other slides. Let me share that. Okay, so you should be seeing the other slides. And I'm pretty sure it's the same. Okay, we've talked about all of this. We talked about the while loop and these examples. There is in Python, you don't have this, but in other language, you do have other ways of writing a while loop. So there's the do while, for instance. So VB.NET, I believe, has it. And it's so far we've learned that we always write for or while at the beginning. But if you notice here, the while is at the end. So you do statement, while condition. So the way this is structured is that at least you always do the statement once. Whereas with the for loop or the while loop like this, there's a chance that the statements inside will not get executed. But when you use this structure, the do while, that do while structure does basically mean that you're going to perform the statements at least once. Do until, similar idea. And then we talked about this, the for loops, for counter, so on. Count control loops, we've talked about that. Yeah, running totals, sentinels, we talked about those. Nested loops, okay, all right. So that's, all right, so let's go ahead and turn on, before we do like examples from the book where we do everything, let's just do that nested loop, the input validation and the mod. So I'm gonna bring up the Jupyter notebook. Okay. And we're going to look at an example of how to do those things I talked about. So I'm going to share my Jupyter notebook, and that's what you guys should be seeing now. Okay, so let me know if you can't see this for whatever reason. But all right, so let's think about that clock, right? So that clock says we want to print, let's just think about it. What we want to do is we want to print, what does a clock have? Let me look at my phone. It's got the hour and the minutes, right? And then we would have the seconds probably, right? So we want to have, let's say hours, comma, and then there's a colon, right? That's usually, and then comma seconds, no, minutes. And then we've got seconds possibly. But let's just keep it simple actually for now. So that's what we want to do, right? We want to print those out. Okay, so we probably want to create a variable hours. And hours can be just a regular integer. Minutes is also an integer, right? We know the range in hours. It goes from 0 to 23, right? 24 hours, or 1 to 24. It's military time, or we can just do 1 to 12. Minutes will be 1 to 60, so 60 minutes. Okay, so that's what we need to do. So we want to print this out in some way. And so we're going to say, with a for loop, for I in range. Now, if you want to, you don't have to use I. Notice that I called these variables hours and minutes, right? And we can change the name. But let me just say here for hour, just so that it implies. And so I'm going to say for hour in range 12, right? And now I have 12 hours. Okay. Then I'm going to do for minutes. So for minute in range. And what's the value in the range? What's the value there?
12.
12 minutes?
Was 60?
60, right? 60 minutes. Right? So it's it's 12:26 right now. So somehow it's because you know it's maybe we want to make it military time, or you know it doesn't matter. But this one is 26. Okay, so it's gonna go 60. All right, so to simplify it, actually, given that it's noon right now, let's just make this 24. All right, so 4 hour in range 24, for a minute in range 60. And so now what do we need to do? Well, actually, we can just print it, right? I'm going to move it here, and then 1, 2, 3, 4. And I may not even need to use these variables. I can just use this. And that's so that's going to be a lot. That's going to be 24, 60. That's going to be a lot of numbers. So one trick that I like to do, because I don't want to print out all of this to make sure it's working, is I just put an input. And this allows me to kind of pause it maybe. So you can try that. So let's go ahead and try it. We actually didn't use these variables, so I'm going to take them out. And I'm going to save, and I'm going to run. See, there's 0, 0, right? And enter 0, 1, 0, 2, 0, 3. You see that? Because the problem is this would have filled up the Jupyter, and I didn't want to do that. All right, if you look here, 55, 56, 57, 58, 59, boom, 1, 0. So it switched. So you see that you created a clock. And you created a nice little clock there. Obviously, you would probably, when we look at doing GUIs and things like that, it'll be better because, you know, here we're in a console, so we kind of print out the next statement. We'd have to clear the console for it not to move, but you can do that on a terminal usually. But when we start looking at GUIs, it'll become a little bit nicer, like a clock. We will probably do like a countdown, you know, like you see in the movies, and there's a bomb and it's like 3 minutes and counting, that kind of thing. So that's let me clear the kernel here. So are there any questions about this? Did this make sense, guys? The two nested loops? Any questions?
It made sense to me.
Makes sense to you? That's great. Yeah. So this is good when we do arrays. When we start looking at arrays, we will use this again to kind of iterate through different values. You know, there's different kinds of problems that we can take a look. But that's, for now, I guess it's a simple introduction to the for loop, the nested loops. Right? So you have one loop and then another loop in there. Okay? All right, so it seems like there's no questions. So I'm just going to go ahead and move to the next example. I'm going to write it there. So the next example will be the modulus that I was talking about. So the modulus, if you remember, what I said is it gives you the remainder of something. So for instance, this is useful if I want to print a statement. Let's say I want to print the index I, but I don't want to print it every time. Let's say that I'm running a really big job that's 1,000,000 iterations. I don't want to look at the output of every 1,000,000th iteration, right? Instead, I just want to look at the output at, you know, I just want to look at the output every now and then. Okay, so what I can do is, let's say that I'm going to create a for loop for I in range 1,000, right? But I don't want to print 1, 2, 3, 4. I don't want to print every single time. I only want to print every 100th time. So I want to print that, you know, 100, 200, 300, you know, and so on. But if it's 88, 182, I don't want to print. I want it to execute. It's going to execute. I just don't want to print. So in that case, I can do if, and then I can do the modulus. So in this case, I would do, oops, I mod 100 equal 0. All right, so if I do that, you know, I do that operation, it should be 0 when the remainder should be 0 when I do that operation for every index when it's divided, when it's modulus by 100, only when it's 100, 200, 300 will it be equal to 0. So then I can do 1, 2, 3, 4, right? And hopefully this, you know, as it's iterating from 0 to 1,000, it'll only print 100, 200. So let's try it out. All right, so we're going to go ahead and run it. Invalid syntax. What am I doing wrong? Got the parentheses, right? Okay. You guys see that? So even though it's iterating from 1 to 1,000, it's only printing when this condition is met. And the modulus is used for that. It's a very common operation that I'm sure you will have to use at some point. So you can see there that's use of the modulus. All right. Any questions about this one? No questions? All right. So let's do then the other one I wanted to do, which is input validation. So in this case, let's do, let's say that I want to get to this one, but I only want to get to this one until the user has entered a valid an email, let's say. And I'm just going to say that a valid email is anything, any string that contains the @ sign. All right, so I'm going to do that. Then I'm going to say email equal input. So the user will enter an input. So maybe I should say first print enter your email address. Okay. So once you do that, you will enter your input, and then I'm going to do let's try a while. while and then I'm just going to say this again. All right, I'm going to say that again. So you're going to display the message, print, enter your email address, email input, and you're going to stay in that loop until you've met the condition. So here we can say, let's think about it. So while @ in email. But that's what we want. So then we should probably say, well, not @ in email. So that's kind of the logic, right? The pseudocode, if you will, of what we would want. Okay, so let's try this. Let's see what it does. Run it. All right, enter email address. So I'm going to say just Purdue. Didn't like it. Dog. Didn't like it. Cat. Doesn't like it. Now if I say cat at email.com, there we go. See, it liked it. And now I was able to execute the other part, which is the other loop. So if you see, this is an example of an input validation. So we actually did, maybe I should have added this. So here we did 2 loops. The for loop was the main event, if you will, the main thing we wanted to do. We wanted to print those values. But before that, we had a while loop that wanted to get some input. Now, why, maybe validation or something. So it's all, it's like a very simple password, right? Password entry dialog, but it only allowed the script to go through when this symbol was in email. So this is an example of, an object within another object, right? So it was looking for the @, which it found here. Okay? Are there any questions about this one, guys? Any questions? Nope. Okay. All right, so no questions then. So I did the 3 examples. So now let's look at examples from your book. So that's kind of how I'm going to wrap up this chapter then. So this is the chapter on loops. And now I'm going to do a complete one of doing all the steps. And then as usual, I'm going to assign, 4 to 5 problems for your homework, which will be due 1 week from today. All right, so there's, here's one. All right, so let's do a couple of these, maybe we'll have time. I'm going to switch over to the whiteboard. All right, so you should now be seeing the whiteboard here. Okay. All right, so let's go ahead. Okay, so here we go. Let's look at one problem. I'm just going to do the first one. So it says, so it's a bug collector, right? Total bugs. So I'm going to read the problem. A bug collector. So a bug collector collects bugs every day for 7 days. Design a program that keeps a running total of the number of bugs collected during the 7 days. The loop should ask for the number of bugs collected for each day. And when the loop is finished, the program should display the total number of bugs collected. Okay, so that's the problem. So let's go ahead first and let's take a look at the let's start with the pseudocode. All right, so first we're going to do the pseudocode. Okay. So we'll do the pseudocode. All right, so we need 7 days. So we're going to create a constant integer num days, which is going to be 7. Okay. Then we're going to do some variables. Put a comment here. Variables. And I'm going to say declare integer. And I have day. All right, then we're going to do declare integer bugs today. Then I'm going to do declare integer total bugs. Total bugs. Okay, and that total bugs, we're going to initialize it to 0. We're going to say it's, there's no half bugs that we're going to collect, although I would imagine there's half bugs. But all right, so now we need to create a for loop. So we're going to use for, and in pseudocode here, it's a little bit different than in Python. I honestly, to me, it doesn't matter. So other people would say that you have to be very precise, but so either way, you do it more like the Python way or you do it more like the pseudocode way. I'm going to show you both just, so that you're aware of it. So if you were doing this in C, I might as well just show you. You would write this as for day equal 1, semicolon, where day less than or equal to num days, semicolon, day. Oops. Day plus plus. You do something like that, right? It's great, you know, it's C's way. We don't do it like that here. If we are doing Python, we would do probably for day in range num days. Colon, right? So that's the Python way. In pseudocode, we're going to do for day equal 1 to num days. The idea is still the same, 3 different approaches, but the exact same idea there. No difference. Okay, so once we end the for loop, we're just going to display a message you collected total bugs. Oh, not a. So total bugs, comma, bugs. Like that. Okay, so then in here then, now we need what do we need to do? We need to count the running total. It's just a very straightforward accumulator. So we're going to say, print statement display how many bugs did you collect on day, comma, so this should be colon, double quote, sorry, then comma, on day, and then you specify day. So it's going to be like day 2, day 3, day 5. If you put an if statement in there, you could also change the number to the actual word. Well, actually, there's a better way. There's another way that we could do that. So if I could put a list here in Python of the actual words. So I could say Monday, Tuesday, and so on, all the days, and then it's going to iterate for day in list, right? So I think I already discussed that before. So that's another way of doing it, but we're not going to change it. We're just going to do it this way. So we do this. Then we do input, obviously. Input bugs today, which is that one. And then we have the final set, total bugs equal total bugs plus bugs today. And that's it. Does this make sense, guys? Are there any questions? You guys still there?
Yeah, I'm here.
Yeah, all right. So, and that's it, right? So that's the pseudocode, declared some variables. We got the for loop going there. And then we display the result. So we did that. Now let's go ahead and look at the flow chart. We need to do an example of the flow chart always. So in the flow chart, we are going to do pretty much same thing. Start, then set the declare operation is going to be a box. So we're going to say constant integer num days equals 7. Declare integer day declare integer bugs today. And then declare, a lot of declares. Declare integer total bugs equals 0. All right, so that's the first box. All right, then we're going to set day equal 1. All right, and then we have the conditional of the loop. Right, and here I'm going to run out of room, so I'm just going to say A, and I'm going to continue that. This is going to be the false clause. So the question is day less than or equal to num days? Right, because that's, you know, kind of the same thing we had over here for I to num days. So we're going to stop when day is greater than or equal to num days, but not before. So if it's true, I'm going to have to continue in that direction. Or actually, let me just do this, B. And I'm going to continue over here. And I'm going to say, if true, I need to do all that, right? So I'm going to do display how many bugs collected on day right? Then I'm going to do input bugs today. I'm going to do input bugs today. Again, like that. Then I'm going to set the bugs total bugs is equal to total bugs plus bugs today. All right. Okay, and then I'm going to say set day equal day plus 1. Right, so that's everything in that loop. And then now I'm going to say that this goes to C, where C just returns to the loop over there. Okay, so that allows me to complete that section. And then I just have to complete A, which I'm out of room here. So A will have to be then finished over here. And I'm just going to say A is, once I have the total result, I'm just going to display total collected right, and comma total bugs. Should be total bugs. And that's it. At that point, we're done. Just hit in. All right. Are there any questions about this one? Guys, are there any questions? No questions? Okay. Let's see if I can find something else that's a little bit more interesting. So is this making sense, guys? The loops, are you understanding?
Yeah.
Okay, great. Great. All right, so I'm trying to see what is there anything you would like to see in particular, or do you want me to just do another example that I pick?
Can I see this in Python?
Oh, you want to see this code in Python?
Yes.
Okay. You can do that. All right, so let's see. Okay, so it's pretty straightforward. Just accumulate the bugs. Go back to the Jupyter notebook. All right, so I need to specify, to make it a little bit more interesting, I'm going to do what I had said. So list of days, and I'm going to make a list of items. So it's going to be Sunday, Monday, Tuesday, right? Tuesday. Wednesday. Oops. Thursday. Friday. And Saturday. Okay. So then once I've done this, I needed those variables. So let's see, I definitely need total bugs. which is 0. And I'm going to do 4-day in list of days. Okay. And then now I need to say, I want to say, print enter number of bugs collected on, and then I'm just going to say day, right? And it should print out on Sunday, Monday, Tuesday, Wednesday. So it should be a little bit more clear. Then I'm going to say I need the current, so current, or what was it, bugs today? Let me be consistent with that. Yeah, bugs today. That those are 0. So bugs today, then input. Remember, this is going to be a string, so you want to probably change it to int. Just like adding these spacings. You don't have to do it like this. I just sometimes do that. All right, and then now the accumulator, so you do total bugs equal total bugs plus bugs today. Right, and then you're done with that for loop. When you finish the 7 days, you can print. So I'm going to say print total bugs collected was, comma, total bugs. All right, so that should be the answer to that. So let's go ahead and run it. Okay, there you go. Enter number of bugs collected on Sunday. Okay, that makes sense. On Sunday, I collected a lot of bugs, 45 bugs. Enter number of bugs collected on Monday. I had 13 bugs. Then on Tuesday, 2 bugs. Wednesday, 34. Thursday, 5. Friday, 100. And then Saturday, 130. Total bugs collected was 329. And you can see that does it for you. Does this make sense? Are there any questions?
No, everything's really straightforward with all of this.
So let's try another version of this. So a little bit more like the code I want to do for day in range. But now I have several problems, right? I still want to print the day, but I have this. So how can I solve for that? What do you guys think?
Would you take your list and put it in the parentheses? I'm not sure.
It would not work, no.
Okay.
Range needs a number. So we could do like we did before, right? We were able to iterate through all the items, but now I want a number.
What you would do is so the list has 7 days. So would it be the range you would put 7?
But you can't do that manually because that could change, let's say. So
That's true.
so you can't just plug 7. I mean, you could, you know, obviously that would, but how do you solve for that? How do you figure out 7 in the code itself, like dynamically?
Can you take how do I word this properly? You could find how many days are in your list, like doing something like list of days dot like to count how many items there are in there. I'm sorry, I'm not making much sense.
No, that makes sense. The length, right? You're saying what's the length of
Yeah,
it?
yeah. It'd be list of days dot length, or at least in C. That's how it would be.
Right. So just get the length of this, right? So the way that you can do it is then n days length. Oops. And then just in here plug lists of days. You see that? And then now you have n days there. There you go. But we have another problem. I want you to show the day still, not the number. So what do you suggest? What do you guys think?
The first thing you would do in general is make an accumulator for this.
Okay. All I want, so we have everything, right? All I'm saying is here, this currently will print 1, 2, 3, 4, but I still want to see these. Like I want to see Sunday there.
Would you say list of days dot whatever value you're on at the time?
The index, right? That's what you're
Yeah,
saying?
the index.
Yeah, so what I'm going to do is I'm going to copy this one over here. And I'm going to reference it by index. So the index is what? Which variable holds the index here? I'm iterating for day in and days, right? So which one of these will be the index that I plug in there?
It would be n days, right?
Not n days, because n days is 7.
Oh, yeah, that's the range.
If I was printing all the numbers, what would I do? Print what? If I wanted to print the number, you know, print, what would I put there? Every iteration, I want to print the number. So what would go there? Day, right? It's the same as index. So if I did this for I, you know, it's the same, right? But I just called it day. So if I wanted to print day, I just do that. Therefore, I can do the same with this. I can just plug day there. And now it allows me to reference in that list by index. Do you see that, guys? Make sense?
Wait, can you explain that again?
Yeah, sure, no problem. But you can see that I'm referencing. Okay, so you can see here. 6, 23. Boom. All right, so I did the same thing. I just played with it a little bit more. This concept that I threw at you here, this is arrays, so don't worry. If you don't, I just, I kind of just saw the opportunity. So I threw it there at you. But it's the same idea. All we're doing is we're iterating, right? We were iterating. So I'll repeat. I created a list of objects Sunday through Saturday. I have the variables. I calculated because I wanted to dynamically calculate the number of days. So I just took the length of it. It's basically when I use this function, it's like I'm counting how many things are in this list. So 1, 2, 3, 4, 5, 6, 7. Then I did for day in range and days. So that's like saying for I in range 7. That's maybe I should just add a comment over here, and I'm just going to say, so for I in range 7, right? So that's really how you can picture that. So then remember, day or I are like the scoop. Range and days is like the ice cream bucket. So you're grabbing a scoop of ice cream. And then that scoop of ice cream that you just grabbed, the top one was chocolate. Okay, now it's in there. Then the next iteration, you grab another scoop and it's now vanilla. And that's what you plug, what you put there, right? So that's sort of the idea. So what I'm doing here is for day in range and days, which is for day in range in 7 out of 7, print, enter the number of bugs collected. And I'm going to reference each one of these by index. So what that means is that each one of these is an index, actually, that I can reference by. Right, so I can then reference all of these, and then I'm just going to go, oh, list of days 0. Okay, great, because it starts, all for loops pretty much start at 0, and so you're going to say, I grab that element, Sunday, Monday, and so on, and then I just do my bugs today, which is this one. Just collect the bugs, accumulate it over here, and then print the total. Does this make sense? Are there any other questions? Guys, any other questions? Definitely, as far as the list and the arrays, don't worry about that. I'm just kind of showing you this now. And then we have a whole chapter on arrays. Certainly, it'll be something that will take us 2 to 3 weeks because it's quite important and extensive. But as you can see, for loops, are integrated to that. Questions? Let's look at, if there are no questions, let's look at 5.6. All right, so we have. Okay, so 5.6 is on the programming exercises. Let's see. Distance traveled. Right, so I think we'll just have time for this one today because it seems like a long one. Okay, so it says here, the distance a vehicle travels can be calculated as follows. Distance will be equal to the speed times the time. Because, you know, it might be going at, you know, 70 miles per hour. And then, you know, you calculate the number of hours. So for example, if a train travels 40 miles per hour for 3 hours, the distance traveled is 120 miles. Design a program that asks the user for the speed of a vehicle in miles per hour and how many hours it traveled. It should then use a loop to display the distance the vehicle has traveled for each hour of the time of that time period. So here's an example of the output. And it says here, what is the speed of the vehicle in miles per hour? So you say 40. How many hours has it traveled? 3. So then it's, oh, okay. So it's going to show then, pretty easy. So then it's going to show we go to the whiteboard. Right, you guys should be seeing the whiteboard right now. And what you want to show is that, you know, hour and then distance. And then you're going to say, probably do a line and you do 1, 2, 3. And so it's doing 40 miles an hour. So it traveled 40 miles there. Probably want to put this in miles. And then it says 80 and then 120. Okay, so that's really what you're going to do. So let's start with this one then. Again, we're going to do the pseudocode. Okay, so we're going to start with that. So pseudocode. Okay. So we need to get the speed, we need to get the time, and then we need to display the results. All right, so we're going to do module main, and then we're going to declare integer speed, comma time. Then we're going to set some functions. So I'm going to say call get time. Time. All right, and then call get speed, and that's going to be speed, and then call show travel, and we need to provide both time and speed for this one. And then we do end module. So this is, I should say 5.6. Okay, so once we once we do that, we can define some of the modules. So I can do module get speed And then here we're going to say, you know, we're going to use that by ref. So remember integer ref. Okay. Input speed. Okay, so that's, you know, when we do that by ref, it means that these things are linked. So this variable is linked to this variable, which is going to be linked to that variable. Okay, that's just an example of how to do that with that mechanism. All right. So then we do display enter speed. Okay, and then we do input speed. Okay, and then end module. All right, so that's the pseudocode for those two. Then we need to define the other two functions. So I'm going to go to the next page. And I'm going to say get time. Get time. Again, same approach, integer. Integer. Ref. Input time. Okay. Display enter time. And then we're going to say input time. Or input time. Okay. And module. And finally, the last one is the show travel. So that's going to be module. Show travel. Okay, that one takes time and speed. All right, and what we need to do is do the for loop, right? So for hour equal 1 to time. Do the calculation, set distance. So we probably need to declare distance over here. So we're going to set distance equal to hour times speed. Okay. And that, so in the first hour, we were doing 40 miles an hour, then, you know, or that was actually, we were always doing that speed. So it's 2 times 40. It's always 40. And it's 1, 2, and 3. So yeah, that'll work. And then once we've done that, we just display the result. So we do display hour, comma, some kind of space or a line, and then distance. And that's it. and for an end module. All right. Any questions on the pseudocode? Okay, no questions. So let's then do the flow chart. So we've got the main menu. So we're going to do main. And then we're going to say declare speed and time. And then we had the three functions, right? Function calls. So we have get speed. And I usually like here to do it more like this. Get speed. Right, so we have that. Okay, then we need to do get time and show travel as well. Okay, so we can do, we did speed, so we need time. Get time. All right, and then show travel. Which takes time and speed. Okay, and this just goes into end here. All right, so now we just need to define the other functions. Okay, so let's start with show travel. Right, and then we got some of the declarations, but mainly we just got the conditional. And the conditional should be if hour less than or equal to distance. Hour less than or equal to distance. So in the for loop here, we set time for hour to time, not distance. That's wrong. Time. Because you're going to enter the time that you traveled. So you have time here. And you have speed. Right, so you're going to say 3 hours. Okay, so it's going to do for 3 hours. So if false, you end basically. There was nothing to do. So you just do end basically. But if it's true, you want to print out the results. And so if it's true, you're going to do calculate set so we're gonna do distance equal hour times speed. Distance equal hour times speed. Okay, so we do that one. And then we just print it out. So display hour, comma, distance. Okay, and then that should be it. You can increment like hour equal hour plus 1. If not, you go back to the loop. So here, you know, kind of go back in there. Okay. That's pretty much that loop. And the other one, the other flowchart should be pretty straightforward. You just have to do the display, the input, and the return. So both of those are exactly the same. So I'm just going to do one of them. Oops. Just going to do one of them. I'm going to do the get time. Get time. Get time. So we're going to say display enter hours. Right, and then after that, input time. Okay, and return, basically return or something like that. All right, so that's sort of the idea with the flow chart. So in the 7 minutes that I have left, let me now implement this in the Python code so that we can see the full idea. So I went over the pseudocode here, there you have it. And then the flow chart, basically. Now let's implement this in Jupyter. All right, so I'm going to create a new notebook. Okay. And now in here, I'm going to say I need get speed, get time, show travel. So get speed. Get time. Show travel. All right, so those are the 3 functions, right? So we need to define each one of them. So get speed should be pretty easy. Just print enter speed. Speed equal input That should be typecasted. Okay, and then return speed, which means over here we need to capture that. So I'm going to say speed. Okay. Then I need the other one, get time. Get time. Same thing, pretty much this. Enter time. This one can be int because it's going to be hours. Well, actually, it could be 3.5. So. That's time. It returns time, which means this returns time. Now these get passed as parameters, so speed, comma time. So we go over here, speed, comma time. Oh, sorry, that's the wrong place. I need to define another function, actually. Okay. And this function is going to be called show travel. So define show travel. Right. And now I need a simple for loop. This one is the one that gets speed and time. So for hour in time, because it's a number of hours, 3 hours. Do the calculation, distance equal hour times speed. Right, so we're doing 40 miles an hour. First hour will be 40, the second hour will be 80, and then 120. So then all we have to do is print, and we're done, print time, not there. Print time distance. Okay, so let's try this. Let's see if it works. Okay, enter speed. So according to the example, 40 miles an hour. Number of hours is 3. So it should print 40, 80, 120. Ah, it gives me there. Float object is not. Oh, what's my error, guys?
Is it because what it said float is not
Iterable. It's
so
missing range here. You see? You know, I was doing the pseudocode, so the pseudocode put that idea in my head of doing this. But anyway, so for hour and range time, now range time, remember, returns an iterable object. You know, 1, 2, and 3, basically, a list. So now this should work. So if I run this, enter speed 40 miles an hour, enter time 3. No. Float object cannot be interpreted. Oh, okay, so time.
In the define get time, do you need change time equals float to time equals int and then input?
Yeah, yes, good catch. Try it for a third time. Ah, there we go. But 0, 40, 80. It should actually do 40, 80, 120, right? That's what we want. So there's a few little problems. Let's see. Oh, okay. First of all, it shouldn't, one is easy. It shouldn't be time, it should be hour. So that, easy fix. The other one is because things start at 0, right? Instead of starting at, so how could I fix that?
Would you have to like give a range 1 to 3?
Or I could just still use this, but just do this, +1. It's because the first time it's 0 because it starts at 0, but I actually want it to start at 1. So it should say, you know, enter time at 1 hour, 40 miles, 2 hours, 80 miles, 3 hours, 120 miles, right? So the problem is for loops always start at 0. So this is going to be 0 times speed is going to be 0. But if I just offset it by 1 every iteration, then it should work. Enter speed 40, 3 hours, and there we go. Except that I fixed this column 40, 80, 120. I didn't fix it 0, 1, 2. So how do I fix that one? Should be really easy, right? How do I fix that one? Anyone? Same thing, same trick. In where I'm doing this, hour +1. Because this is a string, I would actually, just for convenience, just do it here. You know, I would just say temp hour, and then I would do hour +1 there, and then I would replace this with temp hour. Okay, and that offset should give me the result I'm looking for. So if I run it, 40 miles an hour, 3 hours, there we go. Now it works. Questions? No questions, guys?
No.
All right, good. So it makes sense, it seems. All right, that's good. That's great. So that's all the time we have for today. We'll stop here for today. Be on the lookout by tomorrow for 4 or 5 problems from this, like these, okay, related to loops. I'll try to look for something fun and interesting, but it'll be, you know, 4 to 5, the same thing. You will do the pseudocode, flowchart, and the Python code, okay? All right, so if there are no questions, then we're gonna sign off for today, and I will see you guys again next week on Tuesday, where we will begin a new chapter and a new topic. Okay? Have a good weekend.